Welcome student. Now let us see the experiment. Consider this picture. If we open the plug key and make the current 0 in the coil, the pointer of the galvanometer deflect to a side and quickly come back to 0. If the current in the coil is started again, the pointer again deflect to the other side and then quickly returns to 0. Now when the electrical current is flowing through this solenoid coil as shown in this picture. Now consider this. Solenoid coil is displaced with the respect to the coil. The current is still produced in this coil. So what can be inferred from this two experiment? Even if the solenoid coil is kept stationary, a change in current in a solenoid coil produces a current in the coil. If the solenoid coil is moved towards or away from the coil, we see a deflection in the galvanometer as shown in this figure. Also, the faster as the displacement of the solenoid, larger is the deflection of the galvanometer pointer. If the current in the solenoid coil is changed, a current is produced in the coil, or if the solenoid coil is moved towards the coil, then also a current is produced in the coil. So from this you have been know about Faraday's law of induction. What it tells, if a current is switched on or off in the solenoid coil, a current is induced in a coil. This you have seen in the experiment. Such as induction is also observed when the current in the solenoid coil is increased or decreased. Current in induced in the coil when it is moved aside from front of the solenoid. Whenever the number of magnetic lines of force passing through a coil changes, a current is induced in the coil. The current produced in the coil is called the induced current. Now let us see the Fleming's right hand rule. Hold your hand in this way as shown in the figure. Stretch the thumb, the index finger and the middle finger of your right hand in such a way that they are in perpendicular direction to each other. The position of the thumb indicates the direction of the motion. The index finger indicates the magnetic field and the middle finger shows the direction of induced current. So this shows the Fleming's right hand rule. You have to keep the direction in your mind by taking your right hand. Alternating current and direct current. Direct current, a non-oscillatory current that flows in one direction, is called a direct current. This is a circuit diagram shown for the direct current. Here it is the supplies the electric cell. It can change in magnitude but its direction remains the same. You can see here it is increasing, here it is the stable, and here it is being reduced. This is the graphical representation shown for the DC current. Alternating current, a current that changes in magnitude and direction both after equal interval of time, is called alternating current. This is a circuit diagram shown, and here you can see the symbol is for AC supply. Electric current changes sinusoidally with time. You can see from this graph electric current is changing sinusoidally. Okay, electric current and potential difference are shown by the symbol this. This represents the AC current. So from this diagram it will be cleared AC current is alternating current, increases, decreases, increases, decreases, and direct current, it remains the constant. This two is been clubbed in this diagram and it has been shown alternating current here, and this is the direct current, and these are the two circuits shown for that. In India, the power stations generating electricity, one cycle changes in 1 by 50 second. The frequency of AC is 50 Hz, that is 50 cycle per second. When the electric power is transmitted over a long distance, it is beneficial to have it in AC form as it results into minimum power loss during transmission. The home supply is of alternating current. Now let us see the electric generator. This picture is of electric generator and you can see it is so big. An electric device which converts mechanical energy into electrical energy is called electric generator. Its working is based on electromagnetic induction. This is a picture which is similar to that of electric motor, but there was the split rings, but here there is no split rings. So now let us see the working of electric generator. The copper wire of coil ABCD is kept between the two pole pieces of a magnet. The both end of the coil are connected to the conducting rings R1 and R2 via carbon brushes. Both the rings are fixed to the axle, but there is a resistive coating in between the ring and the axle. The axle is rotated with the help of a machine from outside. Because of this, the coil ABCD starts rotating. The stationary carbon brushes, that is B1 and B2, are connected to the galvanometer, which shows the direction of current in the circuit. Upon rotating the axle, the branch AB goes up and the branch CD goes down. That is, the coil ABCD rotates in clockwise direction. So from this you can say, according to the Fleming's right hand rule, the electric current is produced in the branch AB and CD and the current flows through that. In the external circuit, the current flows from B2 to B1 through the galvanometer. If inserted of a one loop, a coil consisting of several turns is used, the current of magnitude several times flows. After half rotation, the branch AB takes the place of branch CD and branch CD takes the place of branch AB, which means this now becomes C and D and this becomes A and B after the half rotation. Therefore now the induced current goes from C, D, C, B and A. Okay, but the branch BA is always connected to the brush B1 and branch CD is always connected to the brush B2. Hence, in the external circuit, current flows from B1 to B2, that is opposite to previous half rotation. This repeats after every half rotation and alternating current is produced. This is what an AC generator. In this, it rotates in clockwise direction. Okay. Now what do we mean by a DC generator? DC does not change the direction in the external circuit. To achieve that, a split ring is fixed on the axle like a split ring was used in the electric motor. Because of this arrangement, the branch of the coil going upward is always connected with the one brush and the branch going downward is always in contact with the other brush. Hence, the current flows in one direction in the external circuit. This is the way generator is called as DC generator. But this working before that I have explained was the working of AC generator. Now let us see. A generator which converts mechanical energy into electrical energy in form of alternating current is called as an AC generator that we have studied using the Fleming's right hand rule. A generator which converts mechanical energy into electric energy in form of a direct current is called a DC current. that I have explained you after explaining how does the AC generator works. Thank you.